In a 27-kilometer underground ring near Geneva, protons are accelerated to near the speed of light and collided. Here at the CERN laboratory, scientists can recreate the conditions of the universe immediately after the Big Bang. The huge ATLAS detector, which studies these collisions, took several years to assemble, but through animation, we can watch it in a few minutes. Throughout much of the ATLAS detector, there is an intense magnetic field. This is produced by passing current through about 80 kilometers of superconducting cables housed within a large toroidal structure. This enables ATLAS to maintain one of the world's largest volumes of intense magnetic field. It is important to measure the energies of particles which pass through the detector. This is done by a device known as a calorimeter. ATLAS has several types, which are arranged as barrels placed in both the center and at the ends of the detector. The 3,000-ton tile calorimeter is composed of steel and a special material which lights up when particles pass through. The tile calorimeter surrounds a second calorimeter, which consists of lead bathed in liquid argon, which is cooled to -180 degrees Celsius. This is known as the electromagnetic calorimeter. Outside of the calorimeter, there is a further component which measures the trajectory of charged particles called muons that reach the outermost layers. The surface area of this component, the muon detector, is around the size of several football fields. Close to the heart of the detector, several components are designed to measure the trajectories of passing charged particles with an accuracy of close to 1/100th of a millimeter. One component, known as the transition radiation tracker, consists of several 100,000 tubes filled with gas and gold wires. Inside the transition radiation tracker are several detectors built out of silicon and divided into millions of thin strips and tiny pixels. The ATLAS detector is designed to measure as many particles as possible, and further detector modules are placed at the ends to measure particles produced at small angles to the proton beams. Toroidal magnets are placed at both ends of the detector to produce the intense magnetic fields that ATLAS needs. The detector construction is finished with the addition of further layers of detectors for measuring particles which reach the edges of ATLAS. Now let's look inside the detector. Here we can see in more detail the pieces of individual components. The tile calorimeter. The electromagnetic calorimeter. The transition radiation tracker, and the silicon devices. In reality, a scientist would not be allowed to walk through the open detector, but in this case, it illustrates the sheer scale of the Atlas detector. Now we can finally witness the Atlas detector measuring the particles from the colliding protons. A typical collision produces many hundreds of particles, and each component of the Atlas detector is necessary to build a full picture of the collision. If you want to know how it all works, don't miss Episode 2, The Particles Strike Back.